So I will introduce today two speakers from Intel. First one is Goshen Hong. Goshen Hong received his BS degrees from of electrical engineering technology. He majored in industrial automation and also robotics from the University Technical Malaysia, Malacca in 2019. Currently, he is in the process of getting his master's degree about electrical engineering, computer and microsystem. And also at the same time, right now, he is working in Intel, Internet of Things Group, as a back-end engineer and responsible for working on the solution for AI chatbots. And another speaker is Jovi Lee. Jovi Lee received his BS degree of computer science from Taylor University, Malaysia in 2022. It's this year, so he just graduated. She is currently working in Intel, also the Internet of Things Group as the AI software development engineer and responsible for the solution for an LG project. So let us welcome Goshen Hong and Jovi Lee from Intel, bring very interesting topic as marginal tool in chatbots. Welcome.
Thank you, Wendy.
Yeah. Hi.
Good morning, everyone. Jovi, Jizzy. We have our member, Goshen Hong, together with us today. We are from Intel Corporation, and today we are going to share the topic margining tool in chatbot. Let me start with the introduction slide. The margining tool that we mentioned here is referring to rank margining tool, which can be also known as RMT. RMT is a software tool built with the purpose to generate, calculate, and report out the system memory interface code boot DDR training result of timing and voltage margins from the log file. It is always important for us to understand the intention of the topic. Why should we integrate the margining tool in the chatbot? First, Intel has various types of application and tools serving for different purposes, such as design validation, issue debugging, benchmarking, and a lot more. Therefore, the users usually must go through a number of steps to obtain their desired result. What are the steps when the user wants to use the margining tool? First, they need to search for the right application among different types of them. Secondly, download the application. After that, the users need to ensure that the application is able to run locally. We are not done yet. The users will need to take some trainings to learn how to use the application. Lastly, run the application to get the result. There are a total of 5 steps that might significantly affecting the user's efficiency, and we are still not considering the errors or roadblocks that might encounter. Therefore, our solution is to reduce these 5 steps so that the users can use the margining tool easily. How can the users execute the margining tool more efficiently? Our solution is to implement the software application, the margining tool, within the chatbot. By implementing this, the users only need to execute 2 simple steps to get their desired output. First, enter the chatbot, and then secondly, ask the chatbot to use the margining tool for analysis. The margining tool will summarize the critical parameters within a table for users' easy reference. Besides, with the help of chatbot, the users can easily access to the application and the tools all the time. Moving on to the next slide. Let's take a look at the summary flow of how the chatbot will interact with the user, starting with the users communicating with the chatbot. Then, the chatbot will identify the intent of the user to use the margining tool. After that, the chatbot will request the user to upload the required log file to perform analysis. In the back-end side, the log file will be sent to the server that hosted the margining tool. This margining tool will perform in the background so that the user can continue to use the chatbot for query. After analyzing, the margining tool will send the result output to the chatbot. And lastly, the chatbot will return the result to the user. Moving forward to the next slide. I will explain how the user can access the margining tool using the chatbot in more details. First, the chatbot will attempt to understand the user's intention by identifying the intent and response immediately. For example, when the users type words such as, "I like to use RMT," or directly RMT, or a sentence that containing the keyword RMT or rank margining tool, then the chatbot will return the meaning of RMT to the users. At the same time, the chatbot will also ask if the user needs to use the margining tool service. By replying yes to the chatbot, it will require the user to upload the log file for analysis. Next slide, please. After the log file is uploaded, it will be sent to the hosted server for processing. Running RMT might take some time. Therefore, to prevent disruption of user continuing using the chatbot, RMT is set up at a different server. This way, users are allowed to continue using the chatbot while waiting for the result output. Additionally, the chatbot also allows the users to continue uploading additional log file for analyzing, while the file will be added to the queue. Of course, the chatbot also allows the users to query for other topics. And once the RMT is done with analyzing, it will return the result to the chatbot, and the chatbot will display the result to the users. That's the whole flow of accessing margining tool using the chatbot. Next, I will pass to our member, Tien Ng, to continue with the flow.
Thank you, Jing, for your part. Okay, so moving on to this slide. Once the user uploads the log file to the chatbot, the margining tool will begin to take the log file and start the analysis process. The analysis process will take some time, often taking from 1 minute to 6 minutes. Once the analysis is done, the result output from the margining tool is as shown on your right. It is a table consists of important information, which report the DDR training result of timing and voltage margin. This information is achieved by running the margining tool with the log file received from the chatbot. In the output table, which is originally at a different format, will need to be converted to a different image format. Once it is converted to the image format, the chatbot can then receive it and reply to the user. This process happens automatically, and the user will receive the table on his chatbot once the margining tool has completed its analysis. Currently, we can only provide the output information as shown on the right, which is to say, the user will only receive the information in the form of an image. This is not exactly ideal. Therefore, in the future, we have planned to implement a way for the chatbot to provide user with the output document as well. This allows user to download and archive the information if needed. However, this goal has not to be achieved yet. All right, so moving on to the next slide. Over here, you can see the overview of the architecture. In this architecture, you can see the chatbot and the margining tool in action, and look at how they interact with each other. And so now I will briefly explain how the architecture works. In summary, the architecture is separated into two parts, the chatbot and the hosting server for the margining tool. The chatbot acts as a front end for the user. Meanwhile, the hosting server for the margining tool will act as a back end. For the interaction between the user and the chatbot, it has been largely covered by the previous slide. The user interaction flow, as described in the previous slide, will allow chatbot to identify the user intent. The chatbot will then decide to begin the application access dialog, which is as shown on the architecture here, and request for a log file from the user. This log file, which is uploaded by the user, will then be set as a download link, which the chatbot can send over to the margining tool hosting server. The software automation will start the process of margining to analysis. When done, it will be sent back to the user automatically. Now, to elaborate more on this architecture. From the architecture, the chatbot can act as a front end for the user to access a multitude of applications and tools. In our case, user can use a chatbot to access a margining tool with ease. Now, how do the chatbot identify the user intent to start the application access dialog? In our case, we have neural network model inside the chatbot which acts as a classifier for the user intent. This intent classifier can detect user intent from sentences like "I like to use RMT" or RMT. After the intent classifier classifies the desire of the user correctly, the chatbot will start the application access dialog and request for a log file from the user, which is required for the margining tool analysis. If the user doesn't have the log file, the dialog will end right here and then. And the hosting server for the margining tool won't start any kind of process. But if the user has the log file and it has been uploaded, the upload file will be accessed by the margining tool hosting server using a download link. For the chatbot to send the download link to the margining tool hosting server, it will produce a ticket and send over the info using a message queue like active and queue. The margining tool hosting server, which acts as a backend for this architecture, will detect any ticket that has been sent over by the chatbot. This detection will act as a trigger to start the software automation that downloads the log file into the hosting server. The software automation will also start the analysis of the log file using the margining tool which is hosted inside the hosting server. Once that is done, the output result will automatically be sent back to the chatbot. All right, so moving on to the next slide. As you can see from the overview of the architecture, the chatbot and the margining tool is hosted at a different server. This is to ensure the two servers of the architecture does not distract each other. So why do we do this? Why do we set up the margining tool and chatbot to run at a different server? For one, margining tool will not be the only application to be implemented with the chatbot in this future. And this architecture can be used to set up in other applications as well. Therefore, by doing this, we can make sure that the hosting server for the chatbot is less bloated and run more smoothly. Secondly, every application needs a different environment to run, which may be incompatible with the chatbot hosting server environment. Likewise, this allows them to run in parallel and thus more efficient as they are essentially running in a different CPU. Additionally, the chatbot can run while waiting for the margining tool to finish its analysis. This way, user can use the chatbot without dealing with the margining tool inside the hosting server. So since we set up the two servers, how do they communicate? In our case, they communicate using a message queue known as ActiveMQ. Why do we use a message queue like ActiveMQ? This is because by setting it this way, we can queue the tasks one by one as to not to overload the hosting server for margining tool. Since we set up ActiveMQ, a ticket consumer was set up at the margining hosting server to receive the ticket stored in ActiveMQ. This ticket consumer also double up as a trigger for the software automation to run and begin the process of log file analysis. Once the output result is achieved, it is sent back to the chatbot, where it will divert to the correct user using a conversation ID. All right, so this is the end of my presentation. Thank you very much for listening.
Thank you very much with Sang Hong, Jun Hong, and also Joey Lee. Bring this very interesting AI technology speech. And currently, a lot of test to manufactured company also they start to have like an automation program generation like this. Hopefully in the future, this kind of AI technology, marginal tool technology can be using in this field. Yeah. And Any question, please? If you have any question, can put your question on the Q&A box. So I have a question about the chat box. How do the chat box understand the user intent to using the marginal tool?
Okay, so the chatbot understands the user intent with a neural network model implemented in the chatbot. This neural network, referred as an intent classifier, is trained with a variety of sentences, which correlate to the same thing, which is our intent here, the RMT intent. Of course, the intent classifier didn't only train with this marginal tool intent, it also trained with other intent as well.
Okay. Thank you very much. So what is the format of the marginal tool output? And do you convert to any other else before sending back to the chat box?
The original file format of the output of the marginal tool is actually an Excel format. So we cannot send over the Excel, the whole document yet. The table is first converted to an image file, and this image file will then converted into a base 64 string. And this string can be put inside the ticket to be sent over to the chatbot. Okay, so
you suggest using the currently more popular format like Excel and put all of these kinds of information, right? Yeah.
Yes.
Yeah, thank you very much bring this very interesting topic. Thank you.
Thank you to you too.
And thank you very much. Yeah.
And want to thank our sponsors again. JDT Technology, Automation and Intelligent Integrated Solutions. Smiths Interconnect, your global partner for innovative semiconductor solutions. And Teradyne, enabling the next generation of technology through advanced test solutions. Their sponsorship is what made this event possible and free of charge to everyone. So when you have an opportunity, please thank them for their support. And with this, I will wish everybody a great day and look forward to seeing everybody back here tomorrow at 9 a.m. China Standard Time. Thank you.